Good afternoon, everybody. My name is Carl Sawatsky, and on behalf of CTC Train Canada, I would like to welcome you to today's webinar, What's New in SQL Server 2016. So it's been almost a year since its release, and here we are in April of 2017, discussing what's new in this version. Yet as adoption starts to pick up momentum, we're certainly seeing an increased interest in this version and what it has to offer. It's that age-old question, what's in it for me? Should I upgrade? Is it worth it to invest in that upgrade? Well, today to help us answer those questions, we have with us Christian Malboeuf. Christian has over 20 years experience as an IT consultant and 10 of those years as an IT trainer, primarily focusing on Microsoft products such as SQL Server or SharePoint, .NET applications. So a lot of hands-on experience as well as that ability to really communicate that in the classroom. So we're certainly looking forward to what Christian has to share with us today. So that's all I have to say. Christian, we're looking forward to your presentation. Help us understand what's new in SQL Server 2016.
All right, thanks, Carl. So welcome everyone to this presentation. We're going to go over the new features of the product over here in this lecture this afternoon, showing you what could be advantageous to you in simply switching over to 2016. Far and wide, in all my experience with SQL Server, which dates back to version 4.2 back in 1992 was when I first started working with it, 2016 is by far their greatest release in terms of how much has changed in it behind the scenes to increase performance, to increase connectivity, and issues that work with the day-to-day. By far their best product release for SQL Server since I've known the product. So we'll go over these issues over here, these features that you may find interesting that might help leverage your data access at the office. I'm going to switch over to the presentation here for what I have. There we go. Okay. Essentially here, just taking a look at the business aspect of simply switching over to 2016 and embracing issues such as large amounts of data, data lakes, big data, things to that effect. After a survey done out there in the industry, $1.6 trillion, right, data dividend is available to businesses that will embrace data over the next 4 years. Right? This will mean connecting to various different types of data, which may be structured or unstructured, data that we have in our database in well-normalized database tables or data warehouses, which are denormalized, but also data that could come from outside sources like social media, for example, which could be just large, flat information, not necessarily related to anything, but we'd like to be able to peruse through that. Maybe we want to look and see if a certain product that we've released is being spoken of favorably out there in social media, or is it being talked about unfavorably? So why? We want to find out these things. So to be able to sift through that information and derive value out of it is important to many businesses. Right? That number, 1.6 trillion, increases, right, to about 30 by 2020. So again, a lot of data in there being used by many companies, and they want to be able to derive information or value from it using new analytic techniques. For example, being able to not only identify trends and patterns in the data, but being able to make better predictions in the future, right? And we have new tools available to us now to do this. For example, the R programming language, right, which is now available with this suite. And that allows data scientists to dig a lot deeper than we could before with a lot more ease, right? We also want to make this information accessible to more people, right? So being able to present it in a way that is conducive for people to understand what they're looking at. One particular project I had worked with in the past was telemetry data that was collected from snowplows that work around the city here in Ottawa, Canada. And the telemetry collected by the snowplows, when you download the data from their boxes, they're entirely made up of numbers. Usually numbers ranging between 0 and 1, so they're all fractional numbers. Looking at them this way makes no sense at all, but being able to present it in a way that's conducive for the people who take care of saving the city some money, maybe by picking a better route for the snowplow, where there's not that many red lights, where the snowplow just sits there all the time. That's for them to figure out, but being able to see that in a way that makes sense is important. So we have new tools available now, such as Power BI, for example, which has really gained a lot of popularity in the last 18 months. As far as self-service reporting, the entire topic of self-service reporting has really increased in popularity in the last year and a half. There's a lot of demand for training in that particular aspect as well, where people can connect to their data sources, make their own models from it, and then derive their own reports and share those on dashboards or portals where people can consolidate the data and look at it in a way that makes sense to them. Right? And of course, we all want this to happen quickly. Right? In this day and age, it doesn't take too long for people to become impatient with a query or a computer, right? Namely about 2 seconds. After that, this is slow. So we want things to happen quickly, and there are many technologies that have been added in 2016 to simply increase the speed at which we can access or go through these large amounts of data. And this is done by leveraging the fact that hardware, especially hardware related to memory, is becoming cheaper and cheaper, and we have more of it, so we can use that to our advantage. Okay. All right. Good stuff. So yeah, again, in this particular series of questions, this survey that has been going around from the top 20 leading enterprises in there, 200, excuse me, leading enterprises in there, 66% of them are more likely to use in-memory technologies in the future, and that's where SQL Server 2016 comes in, right? With the ability to have in-memory online transaction processing tables kept entirely in memory, so we can very quickly access the data through it and have very little contention issues, if usually none at all. Column store indexes, for example, natively compiled stored procedures designed to work with those, so we can have, again, better performance. And by simply switching to in-memory tables and natively compiled stored procedures, the increase in performance is staggering. In some cases, up to 400% compared to the same table which is kept on the hard drive. And it costs nothing to do this. You simply change a few settings about your table, and you've got in-memory tables in there that can be used. Okay? And again, the increase in performance yields to much faster reports that people get back, faster queries, faster analysis. Okay? Because the tables are also kept in memory, we can also do live analytics. As the data is being perused and changed and updated, we can run analysis on patterns and trends that are happening in real time as it happens, because all of this is running in memory. So it allows us to do that without any decrease in performance. Okay. 60% of these businesses are more likely to empower business users with, again, better visualizations, being able to make sense out of the data that we have. And we have tools built in now available to us to share this information. 140% of them more likely to use the enterprise data lake. A data lake is a term that's often used in there for large amounts of unstructured data, usually flat text data, again coming in from social media or sensor information, camera feeds, you name it, just pure data that's out there in a large storage facility, okay, often in the cloud or sometimes on premise as well, all depending. And we want to be able to get through that data and maybe somehow relate that to some of the structured data that we have, like our customers or our products, things like that. So there are technologies built in to assist you in doing this. Okay, out of that, 50% are more likely to use predictive models, and that's where the data lake, again, comes in. Vast amount of data, we want to be able to analyze it, identify trends, and make predictions to better steer our business. Okay. And 80% more likely to use some kind of cloud service, okay, in combination with their on-premise service, so a hybrid cloud setup. Okay. Again, using Azure, for example, as a provider for your SQL database makes it very easy to provision a server. Usually in less than 20 minutes, your server is provisioned out there and ready to go. Okay. Instead of actually getting a physical box into the business, installing SQL Server on it, having somebody take care of it, and so forth. So all depending on your needs, it can grow, and you pay for what you use in the cloud, essentially. Okay. Good. So there's definitely a trend going there. Microsoft, of course, offering with SQL Server 2016, is the only vendor that's in the 3-leader quadrants for operational database management systems. There's Microsoft in there, right? We have over here the completeness of vision, right? Over here with the ability to deliver, okay, on these items with the built-in features that we have. Data management for analytics, again, Microsoft in the top right-hand corner there, and business intelligence and analytics platform as well. Okay, everything is included in the suite, so we have all the services we need to accomplish this easily, right, and quickly. Okay, good. All right. We also have an industry-leading total cost of ownership as opposed to other commercial products. Okay, for example, in database advanced analytics, right, that is built in with SQL Server 2016. Mobile BI and self-service BI support, again, all built in. Okay, over here. We have transaction processing performance council for data warehousing support, #1, okay, in the testing that have been performed for performance. Okay, built-in extract, transform, and load abilities, okay, with SSIS integration services. Online transaction processing, of course, with in-memory tables, column store indexes, natively compiled store procedures, that sort of thing. These are all things you would have to purchase separately, right, as other features or packages to make work on other systems such as Oracle over here, okay, each one having its own cost. SQL Server 2016 has all of that bundled in some capacity in standard and in full capacity in the Enterprise Edition of SQL Server. Now, since we're talking about this as well, since the release of Service Pack 1 for SQL Server 2016, many features that were only available in Enterprise Edition now become available in some capacity in the Standard Edition of SQL Server. And all you need to do is to apply Service Pack 1. Okay. The features themselves are available not to their full capacity. Okay, so again, they give you some of the candy, not all of it. Okay, but you can try and test these features that would be available in Enterprise and see if they work for you using Standard. Okay, so just by, again, applying Service Pack 1, no purchases necessary. You simply apply the Service Pack and these features open up to you and you can test them out. Okay, so having everything running in memory, end-to-end security, advanced analytics, complete mobile BI support, which is now, again, becoming increasingly popular. All of that is built in, which would be add-ons on other products. Okay, so again, the cost of ownership is relatively low compared to others. Okay. Good. Now, Microsoft has a cloud-first approach when it comes to development of SQL Server. They can quickly produce new features in SQL Server and have the online community test them out, okay, in a testing environment in the cloud. And that yields a very fast cycle for development, troubleshooting, debugging by using, again, the online community to try out features in a safe environment and get feedback from these users, right? So increasing speed of development, proven development since it's heavily tested by an entire user base out there on the internet, okay, being able to react to feedback from these people, right, with agile development, okay, all yields a quicker and tighter development cycle. And once these features have been, for lack of a better term, approved by the online community and tested and see that they're running well, they eventually wind their way into the actual SQL Server product that we purchase. Okay, and so far, as I've mentioned, 2016 is their best release in history. And I'm not just saying that because it's a Microsoft product. Having worked with SQL Server since the early 90s, this is really an incredible release for this one. Lots of advancements. And by simply upgrading and not changing a single thing, you get tons of performance improvements as well as other functional improvements in there. Okay, good. Okay, so speaking of performance here, right, the Transaction Processing Performance Council, TPC, has various tests that they perform, right, -E, -H, all kinds of other types of tests over here. We are the leader with SQL 2016 in online transaction processing, right, for price and performance. The test they did was on a 44-core system running Server 2012. Okay, over here. Leader in data warehouse performance and price for that performance. Okay, over here again with 144 cores on a server 2016. Okay, over there, 38% faster. Okay, with 72 cores there as well. And number one and 40% faster with 44 cores than the leading competitor. Okay, and there's many other performance gains that you get just by upgrading. Okay, faster queries. Faster queries with tables that have value parameters over there. Okay, faster queries with spatial line strings. Memory with 8-column store indexes, which we'll talk about later here, 34 times in this case, just by upgrading, right, and changing nothing about your table. Okay, spatial native functions and so on and so forth. Okay, so lots of improvements just by changing the software. Nothing changes about your hardware. Okay, good stuff. Okay, I have a video here, which I'll share my screen with you. This is from Veronis, one of the biggest payment systems in the country here, and they rely entirely on SQL 2016 to run their business. They process millions of transactions a year. They can't miss a single one, right? People make payments with their debit cards, and each payment usually results in about 3 or 4 transactions somewhere in a database server. So if there's hundreds of millions of payments per year, multiply that by 3 or 4 for the number of transactions they have to process in that year. It's staggering what they have to deal with. Let's take a look at it here. I'll share my screen with you guys and get that going. Let's see. Okay, good stuff. Okay, you guys can let me know in chat if you are seeing my screen all right.
Yep, I'm seeing it, Christian.
You're good? Okay,
yeah,
perfect.
I just want to expand.
Let me start the video here. I'll also boost the sound so we can all hear it properly.
Moneris is one of the largest payment processors in North America. We do about 3 billion transactions per year. Our goal is to offer seamless transactions that are fast, simple, and secure, and Microsoft SQL Server allows us to do that. Security is really the core of what we do. Last year, it was $150 billion globally in consumer credit fraud. So we're pretty excited about Always Encrypted. It allows us to look beyond the scope of what is minimally required to deliver the kind of security that our industry expects. And TAP is now becoming the de facto standard. What it does, if you think about the experiences, it says that all the technology behind that now needs to be super fast. Our target is to have a transaction completed in under a second. That's already a pretty tall metric, and we've seen a 20% improvement with SQL 2016. Not only has SQL 2016 been a really great experience, but it's actually helped us win some new opportunities as a result of our performance. We don't just offer service, we offer great service. Because our business is 365 days a year, 24 hours a day, many of our financial transactions aren't just in-store, they're e-commerce. We really don't have downtime anymore. We don't have quiet time, we just have busy. And with real-time analytics, we're looking to be able to drive data intraday. That's something that we haven't done historically, but now with SQL 2016, that's a capability that we're looking to exploit. For every financial transaction, we have 10 database transactions. So that means that there's 30 billion database transactions a year, all of which are SQL, 100%. 40% of Canadian merchants run on Moneris, and Moneris runs on SQL. We chose Microsoft because we trust the platform to drive our business.
Okay. Good stuff. So let's give you an example of how much data we're talking about here. So they're in the billions of transactions in a year. And again, we can't miss a single one. Okay. Good. So what makes this happen essentially, and they've mentioned here in the video, a 20% increase in performance just by switching over to 2016. We have some in-memory enhancements in there, right? Hybrid transactional analytical processing. Again, because we can load tables entirely in memory, we can analyze how that's happening in real time and again gain insight into how the data is being used, by whom, the trends, the spikes, the dips into the usage of the data, and again, help us steer us the company and make better business decisions, right, to support our customer base. Okay, so the capabilities here are straightforward: in-memory, columnar index, right, over in-memory disk-based OLTP tables. So having everything in memory yields a great increase in performance. And with column store indexes especially, right, over there, they often compress the data that's in there. And I'll demonstrate this in my demo later on. And the fact that we're compressing the data at the index level means less data being used, right, which means more memory being left over for other features and other functions, right? It also means less reading involved. If the data is compressed and I have less blocks to read, better performance in the end. Okay, good stuff. Having compiled functions and stored procedures compiled into .NET code to deal with our in-memory tables, again, yields a vast amount of improvement, okay, in the hundreds of % better than having traditional stored procedures. Okay. Transparent data encryption support, okay, constraint triggers, foreign keys, all that with our in-memory tables. Okay, so unlike the competition, you gain operational analytics, 30 times faster transactions, and 100 times faster data warehouse queries. And as I said, that's a minimal figure there. I've seen 300 to 400 increase in performance compared to traditional indexes and traditional tables. Okay, good stuff. And the application itself doesn't need to change, okay, to support these features. The clients don't need to change, right? We simply allow these features to be used for our tables and for our data warehouses or databases. Okay. Good. Now, 7 years in a row, right, Microsoft SQL Server, okay, is the least vulnerable and the most utilized database product, okay, in there. We have, of course, auditing services built in, okay, enhanced threat detection, which is built on top of Windows Server 2016, so we leverage that, okay. We now have new security features at the database and table level. I'll demonstrate some of these in my demo, like row-level security, okay, making sure that users can only see the rows that they are allowed to see, and they are not aware that certain rows are being hidden to them, right? Or using data masking. Okay, for example, phone numbers, email addresses, credit card numbers, they should appear as stars for most people unless you have the right to see the data there. Okay, so we can transparently hide that from the user. Okay, always encrypted is a new one as well, okay, which is a complement to transparent data encryption. So if the data is stored at a server, typically or historically, the sysadmin could walk over to the server and query that data and see information like addresses and phone numbers and credit card numbers, that sort of thing. We would like to prevent that from happening, right? So by using always encrypted, the data is encrypted at rest, right, in the actual database itself. It is encrypted while it is in flight. Okay, so as it moves from the server back to the client over the network, it is encrypted. So should it ever be intercepted at that stage and looked at, it is still encrypted. And it only gets decrypted once the client receives the data, because the client application is the one that has the key to decrypt it. So not even an administrator at the actual source at the server could compromise any of the information in there. Okay, if that's a concern for you, we have the ability to do this now. Okay, good. So always encrypted over here. The data is encrypted. For example, social insurance number or social security number, all depending. The data is encrypted at the server side. Okay, we have a cipher in there for it. And when it's requested by a trusted application that has the key, the information will appear at the end for the client there. Okay, but as long as it is in transit or at rest on the database, it cannot be read as is. Only a client application with the proper key can decrypt that data and then use it. And it is decrypted at the client side with the client application. Okay, and this is leveraging a special ADO.NET library, okay, a DLL that is available in .NET, which makes this happen. Okay. All right. Now, for large amounts of unstructured data, we do have the R programming language. Okay. Most young students that I get now in the workforce that take courses have seen R in one measure or another at school. So they are teaching it in universities and colleges now in some capacity. Okay, it's a language platform. It's a procedural language that's optimized for sifting through data, for statistics and data science, for trend analysis and prediction. Okay, it's also a data visualization framework to produce, again, metrics, key performance indicators, that kind of thing. And it is open source. Okay, a lot of people think that Microsoft actually bought R itself as a platform. They did not. It is open source. Microsoft simply took R and also developed it as a service, which they called Revolution, right, in this case. And the problem with R as it is in open source, the original version of it anyway, is that it was single-threaded and didn't scale well to large amounts of data, which is kind of like putting spikes on the road, because what you want to do is be able to analyze huge amounts of data with this language, but it couldn't scale well because of its design, single-threaded for small machines. So Microsoft took that platform and developed it as a service on SQL Server that can leverage multiple cores, multiple CPUs, and go through vast amounts of information to, again, bring insight into the data that's there. Okay. So as a community, R is actually very active. Okay, so we have over 2.5 million users over there that are learning this language. And again, it's taught in most university statistics program now, and I've seen that from the students I get, the younger students I get in my classes, right? And there's a whole bunch of active user groups across the world that are there to help each other out, to design and share all kinds of formulas that they found useful in their analysis. Okay. Now there is a delivery network available for this, right? CRAN, the Comprehensive R Archive Network, with over 8,000 freely available algorithms that people have designed. Okay, test data to work with so you can play around with it, evaluations, right? And many will scale to big data environments, okay, in that sense, especially with the service that Microsoft has created out of this, which scales well to large amounts of data. Right. Good. Yeah, so there's the Comprehensive R Archive Network. There's all kinds of algorithms here you can download for all kinds of analysis for all walks of life. Okay, over here. Bayesian inference, right, over here. Chemometrics and computational physics. There's all kinds of practices, studies, and fields of study in there that are available for analysis using all kinds of algorithms in there. Okay. Amazing stuff, and it keeps growing every day. Okay. Good. So as a service, right, Revolution Analytics is a statistical software company, right, focused on developing open source and scalable versions of free and open source software. Microsoft worked with those to enhance R to be, how should I put it, better suited for large amounts of data again. Okay, and you'll get very familiar with that icon here. A little monkey icon is the icon they have for R services. Okay, good. So we can perform some advanced analytics, right, using this language. Okay, it's a procedural language, and things like fraud detection, sales forecasting, warehouse efficiency, predictive maintenance, all of these things can be derived by using R. So for example, if I'm using my payment card at a certain location, and then 15 minutes later it's being used at another location, and there's no way I can be in that other location in 15 minutes because by geography, there's way too much distance between these two things, fraud detection will kick in. There's no possible way you could be in these two places within 15 minutes apart, right? So we have all kinds of algorithms to figure these things out based on geography, where the payment is being made, that sort of thing. There are formulas for this, and now R can leverage that as well. Okay, so data scientists can interact with the data, and data developers can manage the analytics and the data together, okay, using this language. Good. So this saves a step, essentially. We don't have to move the data into a staging area using an ETL process just so we can analyze it. We can connect directly to the data and perform our analysis there with R. Okay. Faster deployment of our models for this, okay, for our either our multidimensional or our modeling abilities that we need. Okay. Mitigate the R memory and threading scalability limitations that were there previously. Now we don't have to deal with these limitations anymore. Okay. And the script availability. Again, it's an open source community with lots of algorithms available to you. Okay. Good. So should you ever want to learn more about R, there are many courses available on that. There's also lots of online groups as well, okay, where you can learn up more about R itself as a language. Okay, reporting services. There's been some enhancements in there in SQL 2016 as well, okay. For example, support for HTML5 and cascading style sheets. Okay, there's been a big overhaul of the user interface, okay, to make it, again, smoother experience for the end user looking at them. Okay, Microsoft has acquired a company called DataZen, okay, to increase the support for mobile reports that will display better on smaller screen sizes like phones or tablets, okay, as well. Control over the parameter layout for your reports if they require parameters. More visualizations, richer visualizations, the ability to interact with the report, right, pin or drill down, make your own dashboards, that sort of thing. Okay. Cross-browser support, mobile support, and again, ability to display the data in a variety of environments. Okay. They've made it very straightforward, and I can share my screen with you and show you some of this here. Let me go ahead and do that. Let's see. Just to give you an example of the tools available here. All right. I'm just going to launch the SQL Mobile Report Publisher. Okay, this is a built-in tool over here. Okay, so I'm given here a master template with various cells for my screen sizes, and I would just like to prepare a couple of reports here. Let's go with a totals chart. There we go. We'll use 3 by 2 for that. Okay, there we go. Maybe a pie chart underneath this. There we go. Maybe 2 by 2 for that one. Okay, things like that. And each one, of course, can have a name. Something like that. Okay. I don't need to see the percentages. Thank you. All kinds of little tools and options I can do here. And for my pie chart over here, we can salesperson performance, for example. Okay, and I'd like to see the legend on that. Thank you. Like so. Now I can specify for what kind of data I want to apply these two charts for. Okay, so if I go to the data tab over here, this is simulated data that comes with the product, so you can just pretend and see what your reports are going to look like. But for my purposes here, I'd like to add some real data to this. I've got an Excel spreadsheet. I could also connect to a SQL Server. I've got an Excel spreadsheet with some report data here with 2 sheets in them, salesperson, sales by salesperson, that is, and top 10 selling products. So I'll just include both worksheets in there and assign them to each particular item here. So for my top 10 sales by product over here, let's use the top 10 selling products over here for that one. And here are all the products. I'll just make sure I include all of them so I can see what I've got. And salesperson performance here, again, I'll base that on my second one, sales by salesperson. Okay, here, and I'll include all the salespeople in there. Make sure that we see everyone. Okay, good. I could specify here in my layout that, yeah, we're using a cell phone here, so let's change the layout to that. And now, again, I can drag and drop to fit the relative screen size of a cell phone, like so. And just put this one over here, maybe like this. And a little bit of space left over there for other things, that's fine. And I can preview that. Okay, there we go. So again, it took me less than 5 minutes to crank out a report that could then be shared on report server, and mobile devices would be able to present it properly. Okay. The last course I was teaching for Power BI, one of my students had an Apple Watch, and since it supports iOS, the student was able to download the app for their watch, and they were able to display mobile reports on their watch and even set up alerts so that if the report ever has a certain threshold that is met, the report is pushed on their watch automatically so they can see it wherever they are. That's kind of cool, and again, that's all built in, okay, with the product over there. Okay. Good stuff. Okay, one feature that I've used quite a bit since its announcement in 2016 is by using the query store. Okay, now as a DBA, if some of you are DBAs out there, you may be in a situation where certain queries will run fast 1 minute, and then running the same query again a few minutes later will run very slow. And nothing has changed about the query. They're exactly the same. It's the same query text, but it seems to vary up and down in performance based on some kind of design that we can't really identify. Okay. Before this feature arrived, Query Store, right, we typically had to do a lot of investigating to find out what caused the query to run slowly or quickly from one moment to the next. And that often involved using dynamic management views, auditing, tracing, right, to try and find out what was the cause. And usually in the end, the cause was that SQL Server was not choosing the optimum execution plan. For one reason or another, there was a better plan available, but it went with a worse one instead, maybe because of parameter change or a statistics change, or there's been a change in the indexing, and that affected its decision in choosing the optimum execution plan. And that usually took a lot of time to investigate all that and to use all these queries to finally get a clear picture of why. With Query Store, essentially, they call it here, this is very accurate, they call it a flight data recorder for your database workloads. It records all the queries that run on your database and also records the execution plans that were formulated and chosen. Right? And over time, you can see a graph of all the execution plans that you have for that query, and that's the middle part of this slide here where you see all the little bubbles in there. And I can see over time, most often the same execution plan was taken, but sometimes another one was available, that sort of thing. And the one at the top is a bit slower than the one at the bottom, which is in purple. Right? I can now compare my plans. I can now pick one and force that plan to be used always. Right? So I can enforce a plan which I know to be better than the others. And now SQL Server will not even have to guess. It will always use the better execution plan that I chose to force. There's actually a force plan button, if you can see it there on the slide where the little bubbles are at the top, force plan. Right? And that will direct and hint SQL Server to use that one, which I know to be better. Okay, I've used this quite a bit now since it's been out there, and it really helps, again, leveraging the performance of SQL Server. Okay, and it simplifies troubleshooting queries that run erratically and why. Okay, we can quickly identify which one it is and which plans are involved. Okay, good. That gives you better insight into your workload performance, and this is part of, when I teach DBA courses, this is part of your day-to-day, right? As a DBA, you constantly monitor your server because the queries that people run today are not the same queries that people will run 6 months from now. And you always have to be up to date on what kinds of queries your people are submitting, and this will greatly help you see what's going on in there. Okay? And it also leads into better index management as well, okay? Because you simply know what kinds of queries they're dealing with. Great feature, that one. Okay. Temporal Support is a new feature as well. Okay. With Temporal Support, SQL Server is able to record all changes that has happened to a table in a separate table, essentially. I call it the shadow table behind it. Right? And you are now able to produce queries where you can say, I need to see what this value was at 6 months ago. Right? For example, the exchange rate. Right? The exchange rate is overwritten every day, several times a day, as the exchange rate changes. But because it's overwritten, I can't go back in time and see what's been done to it unless I have a means of recording those changes. Now, before we used to have that, we could have auditing turned on. I could have a trigger that records all the changes into a historical table, that sort of thing. Well, now it's built in. Okay, without changing my table itself, I can simply tell it to have Temporal Support built in. It will create a shadow table behind itself and start recording all the deltas that have happened. And I can then query in Transact SQL with a few new keywords to show me the values for that particular column before this date or between this date and that date. When did it change? That sort of thing. Okay, with minimal change to my database design. Okay, very easy to implement that one as well. Okay, so if that's something you need, right, some kind of a trace on your database tables, it is built in as well. Good. There has been enhancements into analysis services as well. A lot of them behind the scenes. Okay, some of them we can actually work with as well. We have better modeling in analysis services. We now have many-to-many support, okay, in all scenarios, and bidirectional cross-filtering, okay. Support for time intelligence. This is, again, all behind the scenes. What we can work with, however, is there's been over 50 new DAX functions. Data analysis expression functions have been added to work with time, date, different values, better math support, trigonometry. All these functions have been added in there. And again, better performance because of the other performance enhancements that have happened in SQL Server. They trickle down into SSAS as well. Okay. Support for parallel partition processing using multiple CPUs for large amounts of data. Okay. We now support Netezza as a data source as well. We got support for that. Performance improvement in multidimensional mode for your cubes, and support for the database consistency checker. So we can scan our cubes for consistency and errors as well. Okay. And support for Power BI, of course, as a tool for creating reports. We can hook in directly into analysis services and use Power BI there to produce reports. Good. As far as redundancy and reliability, okay, always on, high availability and redundancy there for data recovery. What used to be known as disk mirroring is now deprecated, okay, in 2016. It's now always on high availability, even in the standard edition of SQL Server, where you can have one primary and in the standard edition, one replica, okay. In the higher levels, over there in Enterprise, you can have several replicas, right, in there that will have a copy of the data, and they can also work in load balancing. Right? So if a user is coming in with the only intent to read the data, for example, to produce a report, to read a report or something like that, the request can be handed off to one of the replicas. Right? The primary is busy enough as it is, handling all the updates, the inserts, the deletes, and whatnot. If your intent is to read only, we can direct you to one of the replicas, and you get the same data anyway, and that offloads processing from the primary. Okay, and that's, again, built in, okay, with the product. So smarter failover, a log reader, always on, 2-node in standard edition, so that's, again, built in with standard of SQL Server. Very easy to set up, okay, wizard-based. Load balancing to readable secondaries, okay, again, built in. Fast failover, okay, with now up to three replicas, which can be either on-premise or in the cloud. So your replica could be in Azure as well, okay, where your backup of your database is there, and we can switch over to that if need be. Okay, and the machines don't need to be in a domain, which was a requirement before. Okay, this is a feature now of Windows 2016 that we're leveraging in SQL Server. Okay, so lots of capabilities there added, even for the standard edition. Okay, which is great. Okay. And Microsoft, of course, likes to push their cloud technology, okay, Azure. We can use Azure as a point of backup, right? So we can actually back up our databases and store the backups in the cloud, that is, instead of storing them on-premise. Okay. We can also use the cloud for disaster recovery. So we can have a replica in the cloud as well. And should our primary ever fail, people can be directed automatically by the listener to the cloud replica that we have. And the end users are none the wiser, okay, that the data is actually coming from over there. Okay. Good. Yeah, there's our disaster recovery there as well. Okay. Good. Okay. New feature that many people love to use here is the stretchability. Okay, so if your SQL Server database is taking up a lot of space, and you're running low on actual space, and you do not want to perform a physical upgrade at your on-premise location there for your SQL Server, you can stretch your database into the cloud by writing a simple function which will return a true or a false. Okay. Any records, for example, in the sales table that are older than 2005 need to go to the cloud. Okay, it's a function that will compare the date, okay, of a certain row and see if it's before 2005, and if it is marked to be moved to the cloud. As soon as I create this function, essentially, okay, the background task will start looking at my data and move over to the cloud any row that is before 2005. Okay, when people query the database, however, they are still writing the same select statements as before, and they are unaware that some of the sales data is coming from a local server and the older data is coming from Azure, but they don't see that. Okay, they are still running their selects as usual, right? The whole system works as a single unit with some data here and older data, archived data in the cloud, essentially. And as soon as records become old, if that's the case of my function, they are eventually moved into the cloud automatically. Okay. And again, the end application doesn't have to change. Users don't have to know that they need to connect to the cloud. They simply submit their queries normally, and the data is fetched from both places if need be. Okay. Good. So it's a cost-effective way of storing historical data. Okay. You can either move the entire table, right, or certain rows based on a certain function of your choice. Okay. It is transparent to the users and the applications that use it, right? And it can use encryption and row-level security and all the other features we have there for security in SQL Server. All right. So very popular, this feature there. Okay. It's a quick and easy way to archive data off-site, essentially, but it's still available for people to use. Before this existed, if we were really short on space, we could archive that data, back it up, take it offline, and when somebody wants to query that data, we can use an ETL process to bring it back online, and then here the data is now available, you can query it, but that could take a day or a few hours. Now the archives are available all the time, transparently. So our deployment options over here, we have a physical SQL Server, okay, dedicated, higher cost because we're taking care of the hardware and we have to pay somebody to take care of it, right? Higher administration. Moving on to virtualization, where we can run multiple servers on a single hardware platform, okay, makes it a bit more versatile, okay, and resource assignment is more versatile, and less administration costs. And then we can go on to infrastructure as a service, right, with SQL Server in Azure, with virtual machines in there. Okay, where Microsoft will take care of the server for us, back it up every night, guarantee uptime 24/7, 99.9%, right? If ever there's a failure, there's a hot standby that'll take over in less than 2 seconds, that sort of thing. Okay, we pay monthly for that service. Or we can simply use a platform as a service or software as a service, right? To simply have not an entire server made for us, but just a space to store our database in the cloud. Okay, and again, it's promised to be up 99.9% of the time, backed up for us, that sort of thing. Okay, and we simply pay for the amount of space that we need, okay, for the services that we use. And there's nothing on premise, it's taken care of in the cloud. Okay. Good, so popularity for cloud-based deployments is again rising all the time, okay, especially since they make it very easy now to work with. Okay. So your Azure SQL Database is built for software as a service, right, and enterprise applications. You can scale it on the fly without downtime. Okay, so you can simply tell Microsoft, hey, 64 CPUs isn't enough. I need 128 CPUs in my Azure SQL Server, please. At their end, they simply run a script, and within 2 seconds, you've got 128 CPUs. Done. Okay, here's your new monthly fee, by the way. There you go. Okay, we have predictable performance and pricing. Okay. We pay only for what we use, and we can also create elastic pools of performance. Okay. For example, throughout the week, your resource needs are not always a straight line. Right? On Monday, you have a spike. You need more computational power on Mondays because lots of people are doing stuff on Mondays. Then it slows back down Tuesday and Wednesday, another spike on Thursday, because a lot of people are finishing up their projects or whatever, and then a lower spike a little bit on Friday, but that's it. You don't have to pay for the high watermark the whole week. Right? You can set up a pool of performance, and as we need to, we take from that pool when we have a spike, and we put it back into the pool when we're done. And we only pay for what we use. So this elastic model makes it more cost effective, and you can set up a plan with Microsoft for this for what you need. Okay, good. Microsoft, again, will back up and restore the data for you if need be. It can also replicate that data to other points around the globe in their other data centers if you choose to have that, or you can enforce that it cannot leave the country and the data has to stay in the data center where it's been defined, and they will adhere to that as well. Okay, this is a feature they offer. Okay, and a lot of complaints I hear about people who who don't trust the cloud. Very often is people tell me, yeah, but if my data is in the cloud, any admin over there can just walk over there and read it. That's not the case. Okay, Microsoft has very strict rules for that. I've been into their data centers myself. There is physically no terminal that you can walk to and access that data directly. No administrator there can do it. When you submit a request for changes, you want more CPUs, you want more RAM in your virtual machine in the cloud, there is no physical person who's actually taking care of that. There is nobody with a hammer hitting on things or little mice running around in wheels. It's all run through software. Right? And all it is basically, it's a big building with blade-mounted servers into a refrigerated area for air conditioning, and most of it is run through software, and there's no way to actually get to the data physically there. Okay, they're very strict about that because this is one of the service level agreements that they have, okay, with you. Your data is safe. Okay, good. As far as analytics go, okay, Microsoft has different data warehousing appliances for this. You can buy one off the shelf, okay, basically a machine that is tailor-made to be a data warehouse server. Okay. In some cases where you're dealing with so much data, okay, that you cannot buy a machine off the shelf that exists to take care of this amount of information, we have massively parallel processing edition of SQL Server, okay, which is called the Data Center Edition. Okay, can scale up to 6 petabytes over there. In those instances, the machine has to be custom built for you. Okay, essentially, there will be one server with a rack of CPUs in it. Okay, another server with a rack of storage devices in it, and another server with a rack of networking devices in it, and they are all joined with high-speed fiber. And these 3 servers work together to create a super server, if you will. Right? And a custom-based version of SQL Server has to be compiled just for that one installation. It's called SQL Server Data Center Edition, right? And it'll be compiled with that hardware in mind, okay, and that configuration in mind. It's extremely expensive, okay. However, it does give you access to processing very vast amounts of data. Okay, good. Other than that, we have other ways of doing this as well, using cheap hardware, but lots of it, right? We can create Hadoop clusters over here, okay, which is, again, a very popular trend now. So with Hadoop, we can store large amounts of unstructured data across many different servers. One can be the head server to take the requests, and the requests can be spread out to multiple cluster servers who will work in tandem, right, to sift through the data in parallel. It's a more cost-effective way of reusing hardware to get that done. Okay, Microsoft has a service called Polybase, which allows you to join your relational data that is already well normalized, join that with non-relational data. Right? So you can have a common link between the two and be able to derive, again, value from the data that's in there and gain insight. You know, HP, Dell, Quanta can all create for you these custom servers in one configuration or another if you need to. Okay. Purchasing them as appliances, basically. Okay. So with Azure over here, we have a complete end-to-end solution, right? Elastic scale and performance. Okay, scales to petabytes of data with massive parallel processing. Okay, in the cloud, you can pay for that service. Okay. Resizing your compute nodes to make a change in your hardware takes less than a minute. Okay. Faster time to insight than other symmetric multiprocessing offerings, and it's designed for on-demand workload. Okay, so it will grow as you grow. It's completely scalable. Okay, and we can integrate that with our on-premise solution as well, and people can gain insight into the data by producing vast amount of reports with business intelligence in there. Okay, using our services, by scripting it, or by using end-user tools like Power BI, Report Builder, Report Designer, to get those reports to the people that need to see them. Good. All right, reducing the complexity of big data over here, Polybase, right, with Hadoop can be used together to join structured and unstructured data. So I've got some structured data here, which are my customers, for example, that I can retrieve with a transact SQL query. And some of those customers, however, have information in a vast data lake about their car rentals that they've done. And that information is vastly unstructured and basically all flat. Using Polybase, I can join the two different sources together and run a single T-SQL query to get the information I need, okay, in there. Good. Okay, so only Microsoft delivers all this on-premise and in the cloud. One set of common tools, whether you're local or in the cloud, it's the same set of tools. Same language, common transact SQL, whether you're in the cloud or on-premise. Okay. Simple cloud migration scenarios and tools. You can migrate easily from one to the other, okay, and you can upgrade easily as well. Okay, all within one package. Okay, and across the board, over here, oh, before I get to that, Microsoft also gives you incentives for migrating from other products into SQL Server. There's free online training, there's free migration tools, and there is subsidized deployment as well, okay, which is available until the end of June this year. If you want to migrate from a different platform into SQL Server, okay, they do have a path for you. Okay, good stuff. And with everything built in, okay, we have again mission critical online transaction processing using in-memory tables, column store indexes, security, high performing data warehousing, end-to-end mobile BI, right? Advanced analytics, all of this is built in, okay? And all of those things are available in memory for speed, okay, in there. So consistent experience from on-premise to the cloud, same tools, same language, nothing changes. Okay, so a very nice ecosystem that they've got here. Okay, so for those who would like to know more, a couple of links in there to learn more about SQL 2016, okay, and also to apply for a complimentary assessment or proof of concept for a migration. Okay, we have links for that as well. Okay, I'll show a couple of things here before we adjourn about some of the technologies I talked about here. I'll share my screen once again. I'll show you first the column store indexes that we have. Let's see, let me share my screen again. All right, so I've got a couple of tables here, a demo table and demo table CCI for clustered column store index. They don't have an index yet, either of them, and actually looking at them here, let me just do a select on how many rows these tables have. They're both exactly identical tables, by the way. Okay, select, give me a count of everything from one of them. Okay, how many rows are in my demo table? Over here. 9,989,000. It's almost 10 million rows in that one table, and the other one is an exact carbon copy of it. Okay, they're both exactly the same right now. They don't have any indexes in there. That's okay. If I look at the amount of space that requires, we'll look into my tables here and look at production demo table and demo table CCI. They're both the same. Look at the properties for it and the amount of storage that takes to store that 10 million row table. So it takes almost a gig of space over here to store that table, and the row count is again 9,989,000 and so forth. Okay, there is no index being used really. It's just a hash right now, just a heap, and we're good. So I'm going to create a traditional index, a clustered index on the first table, demo table, and a clustered column store index on the second table. Okay, my first index will be a combination of these two columns here, customer ID and person ID, to make it unique. And the clustered column store index will use every column, okay, in that table to create the index. So I'll start with the first one. It might take a minute or two to go through all that and create that for me, because we are dealing with large amounts of data on a little VM, not too long, okay, 8 seconds. And I will create a clustered column store index on an exact copy of that table over here. And we'll just take a look at the difference in space that is being taken up just to have these indexes in there. Okay. So taking a look at the first one again, demo table, properties. Let's look at the storage page. For that one. Okay, so same number of rows as before, almost 10 million. The data space is the same. The index space is about 3.391 megabytes, okay, to store the index, clustered index in there. Okay, that's fine. For my clustered column store index for the same type of table, which is the exact copy of the first one, okay, the index space is 0. Look at the data space over here. Okay, the other one is almost a gig. This one is 38 megabytes now. Same number of rows. Okay, why are we saving all this? Because column store indexes compress the data as well. A lot of it is duplicate data because we're talking about a data warehouse here. In a data warehouse, very often certain column rows are duplicated, and we can compress that at the page level. Compression also leads to better performance because there's less reading involved. If everything is compressed, there's less reads to perform. And that's where you get your massive gain in performance when you have to sift through these 10 million rows. Using a column store index will yield great enhancements in performance compared to traditional indexes because of that reduction in space used. Okay. And I didn't have to do anything special here, just create a different type of index, okay, in there to make that happen. All right, so that could be a feature you can look into as well. Okay. What else do we have? Let's see, for this one over here, I'll get to the right one. For row level security. Okay, again, I'm just showing this off here just for people to look at. It's not something to memorize by heart. I'm going to, first of all, I'm going to prepare my database for this. Let me go back and run my setup. Okay, what do we have here? Good. Okay, yeah, we'll wrap it up in a moment. Okay, I'll just finish with that demo. Thank you, Carl. That time always goes faster than we think. Okay. So what I'll do here while this is happening, I'll finish with this. Here's a function that a user would be creating, a DBA. Okay, the function can be called whatever you like. Okay, and it's based on a certain column from one of your table. In this case, the salesperson column, and it's a function that has to return either a 1 or a 0. Okay, we will return a 1 if the salesperson column value is the same thing as your username. So if I'm logged in as Bob, and the table I'm looking at says the salesperson for this sale is Bob, that's fine, we'll return 1. Or if the user is Gordon. I'm assuming that Gordon is in our sales manager, and Gordon is allowed to see everything, right? All the people's sales, no matter who they are. And with this, essentially this function returns a 1 or a 0 based on the fact that the salesperson column matches your name. Then I can apply that function by creating a security policy. Again, call it whatever you like, okay? And we will add a filter predicate based on that function I just created on the salesperson column for DBO customer, right? And the state is set to on. With this, I can now only look at customer information where I am their salesperson. That's it, okay? And I could also apply another predicate. I think I have an example for it here. Where's my other demo for it? Memory, 1, 2, 3. This one over here. Nope, it's not the one I'm looking for. I could also apply another one. Anyway, we're running out of time. A policy here for also to block, a block predicate instead of a filter predicate. Right? So you can only see the rows you're allowed to see. And if you try to mess or modify any rows you're not allowed to see, you will be blocked as well. Okay? And this function will determine if you're allowed to do this or no. I didn't have to grant anybody special access. I didn't have to create a special role and put people in there. All I needed to do is create a function that returns a 1 or a 0 or not, right? And apply that as a policy against the table, and that's it. When people access this table, this function runs all the time and compares your username with the salesperson of that row. If they're the same, that row is returned to you. If they're not the same, that row is hidden from you, and you don't even know that row exists. All you get is the result set that matches what you're allowed to see. Okay, so very powerful constructs in there. Many other advancements have been done with security with 2016, which could help you out as well. Okay, so I hope this has been helpful to you and that you have better insight in there. Okay, we have 2 questions here to look at. What do we have there, Carl?
Good. Yeah, thank you very much, Christian. That was awesome. So first question was from Reyes. He was asking, can you partition a table and store old data on disk and compress it, and then partition new data on memory? Or does the table need to be enabled for memory?
It's the entire table that has to be enabled for memory. Yeah, so
okay.
You wouldn't be able to split it that way. Yeah.
Okay, good. That was simple. And Reyes, I hope that answered your question. Camilo also asked, how does Azure Data Warehouse compare to Amazon Redshift?
Amazon Redshift, I've had limited experience with Amazon Redshift. I don't think I'd be informed enough to give you a good comparison between the two. So far, I've focused almost solely on Azure because that's what I do. I've started looking at Amazon Web Services, but I can't give you a good comparison as far as performance goes. Yeah, unfortunately.
Okay, good. Well, thank you so much for that, Christian. Again, if there are any other questions, now's the time. What I will do, what I'll leave you with is we have another couple of webinars coming up in the next few weeks. I posted the dates and titles and the URL in the chat box there, one on Microsoft Teams and also what's new in Visual Studio 2017. I think, Christian, you're doing that one as well. Right?
That's right. I'm delivering that one as well.
Yeah, that's on May 5th, so maybe we will see you on that one. And again, if you are looking to learn a little bit more, get more in-depth information, I posted some URLs there where you can find information on upcoming courses. And one in particular, Updating Your Skills to SQL Server 2016 is a 3-day session coming up on May 23rd. And that's something you can attend virtually as well to make it easy for you. So thank you very much, everybody. Thank you, Christian, for this. If
My pleasure.
You came into this wondering, should I upgrade, shouldn't I? Do I do it now? Do I do it later? I'm sure this gave everybody a lot of food for thought to answer those questions. Thank you very much, everybody. Have a great long weekend, and hopefully we will see you soon on an upcoming course or an upcoming webinar. Bye for now.
Take care.